Guys, let's start with this addressing modes. So basically addressing modes, it comes in assignment number question number 3rd or 4th, I guess. So addressing modes basically means that you're writing an instruction. So what are the various ways you have for writing an instruction?
You are currently the only person in this conference.
Defines a addressing mode. Okay. So now basically addressing modes we are categorizing into 3. First one is a pre-indexed addressing mode without write back. Second one is pre-indexed addressing mode with write back, and third one is post-indexed addressing mode. These are the addressing modes we have for single register load and store address instruction. So basically load and store instructions means you can transfer data between one address location and a register. So there are 2 categories. First category is a single register transfer, where you have a single register as a destination and one address location as a source. So you will copy to and fro. Or second way is you can transfer using multiple registers. That means you have multiple registers. You are going to store multiple register content into some address location. So again, address location will be multiple. These are 2 choices of dealing with memory access, right? So both have separate set of addressing mode. The first set of addressing mode is single register load and store addressing mode. That means you have a destination as a register and source as some addressing mode. So you have 2 instructions for dealing with a memory transfer between a register and a address location. One is LDM instruction. Second one is one is LDR instruction. Second is STR instruction. So these 2 instructions we are using for transferring data between a single register and an address location. So for writing this instruction, you should know what are the various addressing modes you have. So basically addressing modes means what are the various ways I can write LDR instruction or STR instruction for my application purpose. So here in ARM, we have 3 categories of instructions, addressing modes. First one is pre-indexed addressing mode without write back. Second one is pre-indexed addressing with write back, and third one is post-indexed addressing mode. So you can see here pre-indexed addressing mode without write back. I have taken an example LDR R0 comma in square bracket R1 and #4. So this R1 and #4 is given it in square bracket. That means they indicates the address location. So we know whatever is given in square bracket indicates a address location. So here I'm using the instruction LDR. So we have seen this instruction quite a number of times in our lab programs. So LDR instruction will load the content. So where will it load the content? It will load the content into the destination register. So in my example, the register is given as R0. So I'm going to copy some content into R0. From where will I copy? I'll copy from some register, that is R1, and I have given an immediate value, that is #4. So here we'll divide this instruction into 3 parts. First part is the opcode LDR. Second part is R0. R0 indicates your destination. In this example, R0 indicates your register. Okay, so that means I am going to load the register R0. So the third part is your source. Your source is R1 and #4. So whatever is given in square bracket, whatever register it be, I can name that register as a base register. So in my example, R1 is called as a base register. Along with base register, I am having an immediate value called that is #4. I'll call this immediate value as offset value. So I have named it into 3. One is my opcode LDR. Second is my destination, that is R0. And third one is a base register and an offset value. So this offset value can be given directly like #4, or offset value can be given in some registers also. So I can give it in any way I wanted to. So here I have given the offset value directly as #4, right? So I have given a precondition here. My precondition is initially R0 is having 0 and R1 is pointing to some value, something called as 0090000. So this is the initial condition I have set, right? For example, I have taken it, and then I am telling that in the memory address of 00900, I have put up the value 0x01010101. So this is a value I have kept in the address location 9000. And again in 9004, I have showed some other value, that is 020202. So these are the values, initial values I have set. This is the initial setup I have given. right? So I have to execute my instruction now. Once I execute my instruction, I am telling to copy some content from R1 and 4. R1 and 4 means R1 plus 4. So you have to increment R1 4 times. After incrementing R1 4 times, whatever is there in that address location, pick up the content and store into R node, right? So now I have to find what is the initial value of R1. So here I have given initial value of R1 as 0009000. That means that is initial value. So when I execute the instruction, I am telling R1 with an offset value 4. Whenever you give an offset value along with this, you can either add the offset value or subtract the offset value. So in my example, I have not given any minus, so it means you are going to add the offset value. So you will add this offset value with 9000. So you'll get the value as 9004. That means whatever is there in 9004, you are going to copy and store into your destination, which is given as R0. So post condition, that means post condition means after executing the instruction, what happened is R0 gets the content in the address location R1 plus 4. So R1 plus 4 is 9004 and it is having the content 0x020202. This content is copied into your R0. So you can see R0 I have put. And what happens to R1? So in pre-index addressing mode without write back, R1 always maintain the initial status. That means whatever was the initial status of R0, it will remain as it is. So here R0 remain as it is. This is a sequence of operations happen when you execute the instruction LDR R0, R1, #4. So I'll repeat this addressing mode once again. So the summary is addressing mode will tell you the various ways for writing an instruction. Okay. So single register load and store instructions are LDR for load and STR for store. So here always we have a single register for storing the data or for loading the data. Okay, so the instruction syntax will be LDR opcode, then you will be having a destination register and then address location. Now this address location always will be given in square bracket. So inside the square bracket, I can have two content. One content is the register and second content is some offset value. This offset value can be given as an immediate value, which I have given in the example #4, or the offset value can be given in some register. Okay. So whatever be the offset value, the meaning is that you have to either add the offset value with the base register or subtract the offset value with the base register. So here base register is R1. You have to add 4 to R1 or you have to subtract 4 to R1. So in my example, I have not given minus. That means you are going to add offset value 4 to R1. So base register is R1, offset value is 4. I have given a precondition here. Precondition means like some initial case I am telling. I am telling R0 is equal to 0 and R1 is having the value 009000. This is the value of R1. And then I am telling the memory address of 9000. That means whatever is there in 9000 is 111, 010101. And in 9004, I am putting the value 0x020202. Right? So after executing this instruction, what happens is this instruction will copy the content from R1 plus 4 and store into R0. So R1 plus 4, R1 is 9000 plus 4 is 9004. So you will go to the address location 9004, see what is there. It is there, the value is 020202. You'll copy that value and store into R0. Okay. And then after that, your R1 will always have the initial value. That means 900 is the initial address of R1, the base register. So that will remain as it is in the case of pre-index addressing without write back. Without write back means you are not going to modify your base register after executing the instruction. Okay. So that is about pre-index addressing without write back. So the next content is pre-index addressing without pre-index addressing, with write back. Now pre-index addressing with write back, I'll explain with the same example. I have given the same example, but you can see in this example, I have end this example with an exclamation mark. Okay, first, before coming into why this mark is given, let us take the same condition. Again, I have set the same value, R0 is 000, R1 is 0x400. You can see the instruction is same, except this last exclamation mark, the instruction is same. LDR R0, R1, 4. So R1 and 4 is in square bracket. That means that is address location. So you have given an offset value directly, that is 4. You have to add R1 with 4 and get the address location. Pick up the data from there and store into R0. So our meaning of the instruction is same. That means the operation is also the same. So you can see the operation is same. R0 is getting the value 020202. Where is the value? In 9004. How I get 9004? By adding base address R1 plus 4. So R1 is having the initial value 9000. So that way it is fine. The only difference is R1 has changed to the new value. That means in the previous example, R1 value was what? 9000. But in this example, R1 value is 90004. That means when you have pre-index addressing mode with write back, you will modify your base register with the newly generated address, right? The new generated address will always be after performing the operation. So here the operation is R1 plus 4. So that is the only difference between pre-index addressing mode with write back and without write back. In without write back, we will not modify the base register after executing the instruction. But in with write back, we will modify the base register. So always when you are going to modify the base register, you have to indicate that with the exclamation mark at the end of the instructions. Whenever I put an exclamation mark next to any register, it means that you are going to modify that register after executing the instruction. And we will put this exclamation mark only on load and store instructions. We cannot put in move instruction or add instruction or anything like that. So we can put this only in your LDR or STR instruction or LDM and STM instruction, right? So that is about pre-index addressing mode with write back. Always remember in example also, if you forget this one exclamation mark, it means the example is wrong. If whenever it is a with write back, it should always end with a exclamation mark, and that too the mark should be with the base register. So here I am telling base register is R1 plus 4, so there you have to put the marks, right? So that is about pre-index addressing mode with write back. Now the third one is post-index addressing mode. So post-index addressing mode means I'm giving an example here. I have given the same example. The only difference is here the square bracket is only for R1. Forget this one. I have done it wrong. There is no ending square bracket here after 4 because you can see the bracket is closing with R1. The only difference is that when you are telling post-index addressing mode, you will give square bracket for only the base register. You are not going to give square bracket with your offset value. Okay. So I have set the same precondition. The meaning of this instruction is you are going to load some content from some address location. The address location is pointed by what? A base register R1 and some offset value. But here I am telling that you have to, in post-index addressing mode, you will copy whatever content is pointed by the base register. You will forget about the offset value. Okay, that means whatever is there in R1, you'll copy that content of R1 into R0. Okay, and after performing the transfer, you modify the address of R1. That means, see here, my R0 gets a value 010101. This value is stored in where? The initial address. So I'll take that value, I store that value into R0. After that, I modify the value of R1. Right? So the difference between pre-indexing and post-indexing is in pre-indexing, always we will modify the base register and then we will pick up the value. In post-indexing, before modifying the base, you will pick up the content pointed by the base register and then you will modify. So in this example, you will just take the value from R1, store into R0 and then modify R1 value. The difference is very minor actually, all the three differences. Basically, operation is same, copying from some address location. How do you find the address location makes a difference. In first case, you will take the address location, add with the offset value and pick up the content. And you will not modify the base register. In the second case, what you did, you have taken the same operation, you will modify your base register by adding with the offset value, take the content, store into R0 and then modify your R1 also in write back. So the third example is post-indexing, where what we will do is, we will not think about modifying the base. First, we will pick up the content pointed by the base register, store into destination, and then modify your base register. So these 3 examples you can verify one more time, right? I'll go back to the previous example. See, first example, there is no exclamation mark here. It means you are not going to modify your base. So I did not modify my base. In the second case, I have an exclamation mark. Operation is same. I have modified the base. In the third case, I have done the same operation, but here there is no exclamation mark. You will not put any mark in post index addressing mode. You will just pick up the data, store it. That means the data picked up will always be pointed by the base. Base is 9000. You'll pick up the value and then you modify your base. So down I have given some more example. You look into this example. So I will take first example 2. Example 2, LDR R0, R1, R2. So, and I ended with an exclamation mark. That means I am going to modify my base. Out of R1 and R2, which one is the base here? Out of R1 and R2, which one is the base? So, out of R1, R2, the base will always be the first register. Okay, that means R1 is a base register. R2 will be what? Obviously, when you are writing in square bracket, the first content will be the base and second content will always be the offset value. So the offset value is your second content, that is R2. Okay. So the operation is what? You are taking R1 as a base, R2 as an offset. So R1 plus R2 will be your address where you have to pick up the data and then store into R0. So, and here I have given the exclamation mark means R1 will get the modified address. That is the meaning of this instruction. So now again, the offset value can be given directly as an immediate value. In this example, I have given immediate value 4. Second case is offset value can be given in some register. The register is what? R2. Now third case is offset value can be given as a barrel shifter operation also. So now we have to see what is a barrel shifter operation. Barrel shifter operations are that shifting rotation operation. So you can see the first example now. So second example, I believe it is clear. LDR R0, in square bracket R1, R2 and exclamation mark. So it means I have my offset value stored in a register. Now look at the first example. In the first example, I have LDR R0, I have square bracket is only for R1. So as soon as you see square bracket only for the base, it means it is going to be post index addressing mode. Because in post index addressing mode, we are not going to include offset value along with your base register. So I have taken R1 as my base register. So that part is done. So first part was destination R0 done. Second part is R1 alone in square bracket. So I understood that it is going to be post index addressing mode. Now where is my offset? Offset is given here R2, LSR #4. So I will again split it into half. R2 is one register. LSR is logical shift right. Logical shift right and then 4. So if you are not understanding logical shift right, you can go back to the notes in module 2. There I have explained how LSR program is, how LSR is executing. LSR is logical shift right. The syntax I'll quote here. The syntax of LSR is you will be having a source register R, any source register starting from R1 to R15. Then you have the operation LSR, then you have a number. The number indicates how many times you are going to shift or rotate. So in my example, I am going to logically shift right R2 4 times. Okay, so this will be your offset value, complete thing, R2, LSR #4. This complete thing is your offset value. So always whenever you have LDR instruction, there can be offset value. The offset value can be given in 3 ways. One way is directly given as an immediate value like this in the example which we have explained previously. Second way is giving the offset value in some register. Okay, so I have given the offset value in R2. Third case is giving the offset value along with some barrel shifting operation. Barrel shifting operation means rotation, shifting, right rotate, left rotate, logical shift or logical shift left or logical shift right. Okay, so in this example, I have used LSR. LSR means logical shift right. #4 means number of times we are going to shift right. Where is the data? Data is stored in R2. Now, complete instruction we'll explain one more time. LDR is load into register some content from address location. So where is address location? Address location is R1. Okay, because it is R1 is given in square bracket, so you will just take the content of R1 to R0. After that, you will change R1 is equal to R1 plus R2 LSR hash 4. I repeat one more time. Here the instruction is LDR R0. That means you are going to load R0. From where? From some address location. Since address location is given as a post index addressing mode, it means I am going to copy only R1 content to R0. That is not the end of the instruction. After that, you have to modify R1. After transferring the content of R1 to R0, R1 becomes R1 plus the result of R2 LSR hash 4. That means after logical shift right R2 4 times, you'll add that to R1 and that becomes your new R1. Okay, that is the meaning of this instruction. Always they'll ask this kind of instructions for explaining, like explain this instruction. Okay, now I think the third example you will be understanding. Instead of LDR, I am using STR. So what is the difference between LDR and STR? LDR is loading into the register and STR will be what? You are storing the R2 content. Okay, you are storing the R2 content into some address location. Now, whatever is given in the square bracket is address location. Now, which addressing mode is this? STR R0, comma. In square bracket, you have R1, comma, minus R2, comma, LSR hash 4. So the difference between the first and the third example is very simple. In first example, I have closed the square bracket after R1. But in the second example, I have closed the square bracket at the end. That means after the offset value, I have copied. So once you have seen square bracket ending after the offset value, it will come under any one of pre-index addressing mode. Now pre-index is having two categories. One is pre-indexing with write back, without write back. So how do you know which is this? Whenever there is an exclamation mark at the end of the instruction, it means you are not going to write back. So the third example comes under pre-index addressing mode without write back. Now how will this instruction executes? In this instruction, my base register is what? R1. And where is my offset? Minus R2 LSR 4. That means again the R2 content is logical shift right 4 time. Okay, that content is subtracted from R1. So R1 minus R2 LSR hash 4. So you'll perform R2 LSR hash 4 once. So you'll logical shift right R2 4 times. After that, you will subtract that value with R1. So since I have given here minus 2, it means R1 minus R2. So what is the value of R2 after logical shift right 4 times? That content is where you are going to copy your R0 value to. So STR means you are going to save the content. The difference, see, syntax of STR LDR is the same. First you will specify the register, second you will specify the address. But operation is different. In LDR, the operation is fine. You are going to copy the content from the address location to register. The transfer is like this. But when it comes to STR, the transfer is like this. That means you are not going to copy like this, as we have seen in ARM. The copy is from R0 to the address location. That's the difference. So here address location you will get by performing this logical shift right operation on R2 4 times and then subtracting R1 with that R2 value. That will be the destination for you to store the R0 value. So many examples are there in the textbook. You can go through it, but in the notes I have not given so many examples. So I expect you people to copy example from this presentation on the assignment. Okay. I think you have some idea about this addressing mode. This is just one addressing mode of single register. Now we have multiple registers also as it. So if this is clear, I can go on to next. So I think there is some problem with the annotated date content I have given previously. So go through this and let me know the feedback. You can have a chat option. You have a chat option here. Just can ping up the message here, I believe. Let me know what is the status.
You are currently